Hello Amautas! No, I know that what I'm going to propose is very difficult, but at least you and I are going to try. Let's see. Try to forget everything you know about physics, everything you've been taught in school or university or on YouTube, and look around, look at the clouds, the light, you'll see things moving. Well, if you really listened to me and completed your mission of forgetting everything, then it probably wasn't very difficult for you to imagine things like movement or forces. But what about energy? Isn't it true that it has been very difficult for you to even grasp the concept of energy? I'm not even talking about the conservation of energy, that thing they teach us in school, that energy is not created or destroyed, only transformed. So after this little exercise, I'm sure you agree with me that energy is not something obvious, immediate, or that can be felt like a stroke of intuition, as happened with motion in kinematics or with force in dynamics. No, energy is an abstract concept, very subtle, full of traps, and that explains why it took so long to master. Although it's worth it, as I have already told you, because this is something fundamental in physics, it's at its very heart. And for that reason, as you can imagine, it is quite remarkable that even in the times of the classics, there was talk of something similar to this energy. Although, on the other hand, it is normal that they arrived at this concept given how obsessed the classics were with the concept of changing. Does it exist? Is change something real? Well, since Parmenides, Heraclitus, Zeno, Plato, they all pondered these questions. They saw fire, the transformation of water, they saw the fall of bodies, the movement of planets, or how bodies decompose upon death, and they asked themselves, is this change real? And it was from all these deep reflections that a wise man finally came up with the concept. It was Aristotle of Stagira who already spoke of an energeia. Yes, you guessed it, energeia is the origin of the word energy, and etymologically comes from the Greek word energos, which means force of work. So you see, this word is quite fitting. Although, to be fair to history, it must be said that as Aristotle used it, the concept was too vague because it did include that intuitive feeling we have of something with energy as it moves to explain that transformation. But Aristotle also associated it with a capacity to be happy or feel fulfilled. In other words, it did have part of the modern idea of energy, but it was broader and wandered a bit more. But things were going to change quite a bit with the arrival of the Renaissance. You know, the Enlightenment, modern science. Well, here we begin to get a little closer to the current idea of energy, particularly thanks to one of its precursors, a very peculiar scholar, the German Gottfried Leibniz, philosopher, mathematician, physicist, humanist. This guy did everything, even played soccer and all, and a great rival of Newton. Well, Newton had already created mechanics with the concept of force, momentum, or quantity of motion as the central axis of this theory. Well, Leibniz saw that it was interesting to define a new quantity that he called vis viva, which is capable of generating momentum, and is basically what we today call energy of motion, our kinetic energy, a type of energy. Years later, the Englishman who became famous for the double slit experiment, you know who I'm talking about, this guy, Thomas Young, abandons the concept of vis viva and returns to that of energy. It was the 1800s, and little by little the magnitude that we all know is being born. The following 2 centuries only served to see this concept flourish, to see how it expanded to include new forms of energy, not just kinetic, the energy of movement, but many more forms like elastic energy, electricity, or magnetic energy, all of them with the same capacity as kinetic energy to generate movement or transformation. In other words, they are in some way sisters of kinetic energy, they are forms of energy. Today we call it potential energy. But if this concept of energy is truly powerful, it's because energy is what pulls the strings of the universe. We have found in energy a way to understand what happens in the universe in a very profound way, and this is thanks to a subtle but very powerful concept. Pay attention because here it goes. The law of conservation of energy, what I call the law of laws. Where does this idea of energy conservation come from? Well, to understand it, we have to travel back in time, and primitive forms of this idea were already seen in classical Greece, with the wise Empedocles or Epicurus. But again, with the arrival of modern physics, from the times of the Enlightenment and reason, it takes the form of a universal law, first with the works of Newton, Leibniz, and then with Émile du Châtelet. We are gradually getting closer to that law we all know. However, all these studies were based on mechanical work that strictly followed Newton's laws and their extensions, such as Bernoulli's hydrodynamics. But there was something that didn't quite fit. All the brilliant mechanical works were formulated in an ideal environment where weight was transformed into motion and vice versa, ideally and continuously. Energy was never lost in these models. In fact, this is what led to that millennial quest for the perpetual motion machine, with very original instruments seeking the machine that never stopped. A search with many legends, frauds, mysteries, intrigues, and unfortunately, it continues to this day. It turns out that the seekers of perpetual motion and the early lords of energy were missing something, a subtle concept, key to closing the energy circle and truly understanding what lies behind it. This sought-after concept is heat. Until the arrival of the 19th century, heat was understood as a fluid that passed from one body to another, transferred. But a saga of scientists and a great revolution later, I speak of fantastic people like Joule, Clausius, Carnot, and also of their works, their steam engines, which led to the Industrial Revolution. And of course, I must not forget my idol, the German Ludwig Boltzmann. Well, they would come up with the theory of heat, thermodynamics in the first case, and with statistical mechanics, which is a more complete extension in the second case. And the rest is history. The energy framework would be completed with modern forms of energy, such as radioactivity, nuclear energy, or Einstein, who demonstrated that mass is a form of energy, already outlining the whole picture. Yes, energy transforms, flows, it travels and changes, and it does so, as we have learned, always conserving itself. It is never created, never destroyed. Now, friends, all the tools were available to better understand energy and its role in the universe. Energy was already in a position to crown itself as the queen of physics, one of the pillars in the understanding of the cosmos. What? So have you felt the urge to learn more about energy, about work, about its forms, and its role in the cosmos? Well, all of this is precisely what we are going to cover in this course. What energy is, its associated magnitudes like work or power, how it is measured and how it is conserved. But we are going to do it by restricting ourselves to the most common forms of energy, also those that were understood earlier since the times of Newton. I'm talking about mechanical energy, motion and gravity, because about heat, radioactivity and other energy sources, well, I think we will talk about those in future courses, don't you think? So hold on tight, fasten your seatbelt, because this exciting journey into the depths of energy is about to begin.
Are you coming? Until the next video.